a cubic block of wood, guys, of side H and relative density S floats in water with all sides either vertical or horizontal. It is to press a distance x into the water and release from rest. Show that it will perform simple harmonic motion and find an expression for the periodic time. So what we're going to do is just draw a diagram. Okay. Now, and then I'm also going to get myself a cube like so. Now guys, what happens is when it's balanced, its weight going down equals the buoyancy going upwards. Now what happens next is I get it and I drag it down. So I'm just going to put another line here, a dotted line, just here. Oh, sorry, never mind. Shh. Get down there. Okay, so I get it and I drag it down. Okay, and what happens is I now drag down where it used to be, and now I have an extra region. So I have an extra buoyancy force now that's acting upwards, in addition to the buoyancy force that was balancing out in the first place. Okay, so to get this extra buoyancy force, the extra buoyancy force equals the weight of water displaced. Okay, so please remember that what shape is this object? What shape is what's the extra shape that we just had for submerging? It's basically a rectangle, like so, and that's basically how much water this. Oh dear, don't want that. This here is basically the extra. See the blue? See the blue shaded region? This is it in 3D. This is the extra area. This is the extra bit that you put underneath the water. So this, hence, is the volume of water you're just after displacing. Now we're told that it has side H. It's a cube, so its width and length are the same. What differs is its height. We're going to submerge it by a distance x. Therefore, our buoyancy force, and we said it's minus v rho g. Okay, what is its volume, guys? Its volume is minus x by h by h. Its volume is xh squared. Its rho value, anybody? 1000. And finally, g value is g. Its buoyancy force, therefore, is minus 1000 xh squared g. Okay? Our next problem is we want to equate this. If it's performing simple harmonic motion, we want to equate this to minus omega squared x. How are we going to do that? Buoyancy is a force. Therefore, what's going to happen next is that F equals ma. We have to find out what m is. Any idea how to find m? The mass, volume, times density. Now, does it tell us what the density is? It says of relative density S. So it's going to be volume. Volume it's a cube, isn't it? So it's going to be h by h by h. H up, h across, h depth. So its volume is h cubed. Okay? So therefore its volume is h cubed. Its density, because we're talking about the mass of the object, it's not 1000, it's 1000 s. Because we've got to multiply it by the relative density. Is that right? And then that's it there then. It's 1000 what's it? 1000 h cubed s is the mass. Now, using force equals ma, we know that the force is minus 1000 xh squared g. The mass of the object, 1000 h cubed s. 1000 cancels, and we forgot about the a at the end, hsa. That thousands cancel. H squared cancels, leaving that as h. And then we're going to get a on its own. So a equals minus g over hs times x. Everybody happy enough with that? Then A is therefore equal to minus g over hs times x. A equals minus omega squared x. What does that mean omega is the same as? Omega squared is the same thing as g over hs. Omega therefore equals the square root of g over hs. Okay. What are we asked to find next, guys? Are we asked to find the periodic time? Find the expression for the periodic time. What's the formula for periodic time? Anybody tell me? 2 pi over omega. T equals 2 pi over root g over root hs, which ends up to be 2 pi root hs all over root g. Okay, that's your time. Now, the next question is quite easy. You're going to use your existing question to answer it. So, instead of being in water, you're now in a liquid of relative density K. All you have to do is go to your last question and see where you had 1,000. Just put in an extra K. Continue it on down to here. There's an extra K hanging around here. Then now it's GK, and then your omega is going to be a K in there and a K in there, and that's it. And then does it say how does it affect your periodic time? Well, it means the G isn't on its own, it's just GK. That's it. It's just a different fluid, so the density value was affected and it carries the same mass. Okay. We have next, guys, is a rectangular block of relative density 0.6, has a height 80, a breadth 50, and a width of 20. It floats in water with its height vertical. Show that its height vertical means that the 80 isn't completely submerged, okay? So that's the height that's affected. Show that 78 centimeters of its height is submerged. Now, do you want to know the really easy way of doing this? The really easy way, and I'll do it the hard way in a second. The really easy way is to know that whatever your relative density is, if it's 0.6, this means that only 0.6 of your body will have to be submerged. So it's just going to be 0.6 multiplied by its entire height, 80, which will give us 48 centimeters. If it was 0.5, it'd be half the height, so it'd be 40 centimeters submerged. Now, to prove this, I didn't like just layering that off. I wanted to know how to do that from first basis, okay? So, if you want to do it from first basis and you happen to forget come test time, your buoyancy force equals minus V volume times rho times G. Now, what we're going to imagine is that our full body is not part of the body is underneath the water. The part of the body completely underneath the water is x. Okay, this is I'm going to put it into meters because I like dealing with meters. Because remember I said that the density of water is 1,000 kilograms per meter cubed. Because it's in meter cube, I need to have it in SI units. I can't have centimeters here, or I don't particularly want them. I'd rather everything in meters. So I'm going to change that to 0.5, and then obviously the depth is going to be 0.2. Okay, so my buoyancy force equals minus my volume. My volume is going to be length by width by height. So length is 0.5, width is 0.2, and my height is going to be equal to x. Is that okay? Now, it's going to be multiplied by rho, which is 1,000, because we're talking about how much water is displaced, and then times gravity. I'm then going to get that my buoyancy force is 1,000, minus 100 xg. Are we happy with that? Buoyancy force going upwards is 100 xg. Now, what is the weight of my object? The mass of my object is its volume times its density. Its volume is zero point 0.5 multiplied by zero point 0.2 multiplied by, anybody? Its height, which is 0. 0.8. Its volume, what's its row value, guys? Its row value is 0.6 times 1,000, which is going to be 600. Multiply all that out, and you're going to get 48G. Compare when it's balanced, the buoyancy going up equals the weight going down. Your minus 1,000 xg has to equal the 48G. The g's will cancel. We'll divide by x. Now, do you see the way they have a different sign? Do you understand what that is? It's basically if I say 20 newtons down versus 20 newtons up, technically one of them is minus 20. So I only need to take magnitude into consideration for it to be balanced. So I'm just going to ignore that minus just for 1 minute. Okay, then x is going to equal to 48 over 100, which is 0.48 meters. That's the long way of getting the same answer as 48 centimeters from earlier on. The difference is I didn't need to learn that one off by heart. Well, this short way you'll need to just know it off by heart on the day. Okay? Now, that's done. What we're going to do next is we're going to figure out what happens when we take this system and submerge it even more. Okay? So look what happens now, guys. So what we're going to have is, and forget x is now the extension from equilibrium, okay? We have a rectangle. It's currently balanced, we have a rectangular block. It's currently at equilibrium. Force equals 0. This is because the buoyancy going up equals the weight going down. No bother whatsoever. Now, what I'm going to do next is I'm going to submerge it even more. So what I've done is, I used to have an equilibrium position here, and what I've done is I've dragged it down even further. Dragged it down by a distance x. Okay? So I've now put a pressure onto the system, an extra buoyancy force. The extra buoyancy force, and I'll be sure to segment this. The extra buoyancy force equals minus phi rho g. The buoyancy force is our volume. Now our volume is going to be 0.5 times 0.2 length by width, 0.5 by 0.2, and then it's going to be the height x. Okay, so the height x is here. The x in this question is different from the x in the last question. They mean two completely different things. If for all intents and purposes, you could just call the last x h. Just say it was what is height underwater. Okay. Now, I need to multiply that by its. Remember, buoyancy equals the weight of water displaced, so that would be 1,000, and then g at the end. So that's going to get me minus 100 xg. Okay, it's the extra buoyancy force that's now dragging it upwards. Okay. Now, what is our force equals ma, like last time? What's our mass of our object? We did it earlier. Its mass is its mass is 48, and its weight was 48 g. Okay, so its mass is 48. So your buoyancy force, your extra buoyancy force equals 48 a. Your buoyancy force is minus 100 xg equals 48 a. I'm going to put in g equals 9.8. So it's going to be minus 980 x over 48 equals a. A will therefore equal minus 245 over 12 x. That mimics the equation minus omega squared x. Omega therefore equals the square root of 245 over 12. We're asked in this question, find its maximum acceleration. Okay, find its maximum acceleration. We dragged it under a distance, didn't we? What distance did we drag it under again? Anybody remember? It was at 48 centimeters submerged, and now it's 50 centimeters submerged, which means that we brought it down another 0.02 meters or centimeters. That's the amplitude of its motion, because you dragged it down and you released it. It has to go back up then. It isn't going to go any further down. It's going to go up. So its amplitude of its motion is 0.02. So to find your maximum acceleration, A max equals omega squared A. Omega squared being 245 over 12. Your amplitude being 0.02 meters. Put them equals and you're going to get 49 over 120 meters per second squared. Okay guys.